In this problem, we have a relation given by x squared equals 7y cubed. And we want to find the arc length of that curve between the points 0, 0 and 49, 7. Now for this problem, we could surely do this using either one of these two formulas. We could solve the equation for x in terms of y and use this second formula down here and integrate with respect to y. Or we could solve this formula for y in terms of x and use this first formula. If we decided to use this first formula and integrate with respect to x, the problem would look a whole lot like the first arc length problem that I did. So I'm going to do this problem by solving for x in terms of y and integrating with respect to y. Solving this relation for x would just mean taking a square root of both sides. I'm just going to call this the square root of 7 times y to the 3/2 power. So as you can see, we need dx dy, so we can take a derivative of this with respect to y. This gives us a dx dy that we can plug into this arc length formula right here. Then all we have to do is integrate from the smallest value of y given, which is 0, to the largest value of y, which is 7. Then that integral looks like this. Let's see if we can simplify and integrate that. Squaring 3 gives us 9. Squaring the square root of 7 just gives us 7. And squaring 2 gives us 4. Squaring y to the 1/2 power just gives us a y, which is great because that's going to make this a little bit easier to integrate. We can multiply 9 times 7. And then we need to recognize that we're going to need to use substitution, where u is just whatever is inside that square root. Du then is just going to be 63/4 dy, meaning that dy is going to be 4/63 du. Making those substitutions gives us a new integral with respect to u. And since we're now integrating with respect to u, we may as well switch our limits. Our lower limit of integration was y equals 0. But if we plug that y equals 0 into this formula up here, we notice that that will make u equal to 1. Our upper limit of integration was y equals 7. And if we plug that into the formula up here, which gives us a bit of an ugly number, it should be 445/4. So our limits are going to go from 1 to 445/4. Well, okay, we can pull that 4/63 out of the integral. I'll call the square root of u to the 1/2 power. And then to integrate, we just need to add 1 to that power of u. And we divide by that 3/2, which is the same thing as multiplying by 2/3. I'm not seeing any cancellations here, so I'm just getting 8/189. And plugging in our upper and lower limits of integration gives us this as our final answer. Now this could be simplified just a little bit. If you want to see how to do that, you can go to the previous video in this playlist, and the last several steps show you how to simplify something like this. But that's such an ugly number that I'm going to assume you're just going to plug it into a calculator. So I will box this thing up and call this problem good. I hope that this helped you out.